Hello everybody, here is Jonathan and I'm just continuing my saga on trying to import the logs from Rubygems and trying to make them be kind of timescale data that we can reuse and start extracting analytics from it. So I just got access to this anonymized production log. We don't have like the IP address here, but if you check here the entire information, you have like a server log cache, which you have the timestamp, and then you have like some IP address that's anonymized. Then you have another timestamp, and then you also have like the gem name, the gem version, what's the Rubygems version, what's the architecture, or like the Linux version, and so on. So I created a small parser here, and just like how in one file that you can also run it and you can also see how it works. So basically I'm using the timescale gem here, and I'm just declaring my download model as the first thing here because we are going to use some of these scopes in the migration. So as you can see here, we declare it as a hypertable, and then we just define some scopes here, like group something by 1 hour, and then I can start like counting downloads by 1 hour. I can also count gems by 1 hour, and also consider like the gem with its version and count the downloads by hour. That's like the main thing that the Rubygems today offer as like let's say the way that it tracks the counters, and that's what we are going to implement. And so here we just create a small migration thing that we run here in this database URL. So if we have the table, we just drop it because I'm just testing it frenetically, and then we create the hypertable with 1 day chunk time interval, and we also enable it compression after 7 days. So all this data is going to be compressed, and it's also going to be like just like the downloads table is just simple as gem name and gem version, and then the count is the record itself, and then we have also payload, which we can just store this type of extra data. Like if we want to do something with the IP address, maybe we can store it. If we want to learn something from the environment, like the Ruby version or something, we can also store it later. And here we go creating the continuous aggregates. So we just use these scopes and declare the names. Like continuous aggregates is like a materialized view that keeps refreshing, and we just say like refresh it every 1 hour and just go and backfill with the last 2 hours. Let's say if you backfill something, it's like fresh data, maybe you received a new log or something, and then you can just like go and refresh a few buckets back, and that's how generally you can configure this thing. So we configure this, and then I also created here CAG as continuous aggregates shortcut for generating this view name that we will need, and maybe refresh it. And then we start here declaring these, let's say, constants that just create this model for all the 3 versions that we have. So we have this, let's say, all downloads by 1 hour, we have all downloads, all gems by 1 hour, and all versions by 1 hour. And then we start getting the file to parse and load the file. So here we just load the gem name, the version, IP, timestamp, environment, and then we build a payload here, and we use also this book insert. So we do like 5,000 book inserts for values, so this is much faster, and that's like a single transaction. So soon we finish the script, we verify if we have any leftovers, and then we send them as an extra batch. So this is the parse env. So the env is just a string, so it says like Ruby / 2.0, and then we say Ruby arrow 2.0. So we can just reuse these as a JSON-B fields and attributes, and then we are just going to benchmark everything here and just see how much it's worth for refreshing everything, and that's all the script, and then we have a binding right here. So let's just run this, and then we can see the entire thing running. So as you can see here, it creates the table, it creates the hypertable, and then it also enables compression. Then it adds the compression policy, then it creates the all by 1 hour view. So this is like a time bucket of 1 hour. Then we have the aggregated policy that will refresh it, and then in the last minute, and then we'll have a very similar query. I don't know why we have these empty spaces here, but that's funny. And we have all gems by 1 hour, and then this by 1 hour we also include the gem name here. So, and then in the last one we have the gem version, so we group by 1, 2, and 3, and then we have the parser loading. So for parsing the file, loading, doing everything, it's like 1 second, and then later for refreshing the entire continuous aggregates in the two, it's like just a few milliseconds. It's really fast. So if we are here now in the terminal, and if I try here all by hour dot first, you can see that we have this data right there, and then we can see here, for example, all gems by hour dot all, for example, and then you can see a few, because these log files, they are just like 5 minutes files. So as you can see, all of them are here. So if you get like here download dot first, we can see that this is the first one. And then if I say here, for example, order by TS desk, and then get the first, we'll see that it's like 5 minutes of data that we have. So this is all in the same bucket, but this is just a representation of the parser, and then we can continue this discussion and also implement the continuous aggregates in other time frames, like make it monthly, make it yearly. This is just like a sandbox, a space to start this conversation. So I'm running Timescale here in a Docker version. That's just like a Docker Compose running locally, and that's also something that is very easy to set up. And now I'm going to make a gist from this file and also attach this video, so you can also test it and check if this is in a good state for proceeding.